Everything you have ever known has an expiration date, and it is written in the sun. The sun feels eternal. It rose before you were born, it will rise tomorrow. But the sun is a star, and every star without exception must die. One day our star will swell into a monster and swallow its own children. The oceans will boil away, the earth will turn to glowing rock. Everything humanity ever built, every memory, every song gone in the fire. This is not a maybe, it is a certainty already scheduled by physics. The only question is how and when, and the answer is stranger than you think. Because the death of the sun is also one of the most beautiful things in the universe. Welcome, you're watching To the Moon and Back. Here we travel to the real places and the real futures hidden in the cosmos. Today, the last days of our star, and the last day of the Earth. It will not happen for billions of years, but it will happen, let's watch it. This is how the world really ends. First, understand what the sun actually is. It is not a ball of fire. It is a colossal sphere of glowing gas, held together by its own gravity. More than 1 million Earths could fit inside it. It is almost unimaginably vast. Deep in its core, it does something extraordinary. It fuses hydrogen into helium. Every second, it turns 600 million tons of hydrogen into energy. That energy is sunlight, it is warmth, it is the reason anything here is alive. The sun has been doing this steadily for 4.5 billion years. It formed from a collapsing cloud of gas and dust, along with the planets. And for all that time, it has stayed remarkably, reassuringly stable. A perfect balance between gravity pulling in and fusion pushing out. But that balance depends on fuel, and even a star runs out of fuel. The sun is about halfway through its life, middle-aged as stars go. It has enough hydrogen for roughly another 5 billion years. Which sounds comfortably far away, and for us it is. But the trouble starts long before the sun actually dies. Because a dying star does not simply switch off, first it gets brighter. As the sun burns hydrogen, its core slowly shrinks and heats up. And a hotter core means the sun grows steadily, relentlessly brighter. About 10% brighter every billion years. It does not sound like much. But for a world as finely balanced as Earth, it is a death sentence. The first catastrophe does not wait 5 billion years, it comes far sooner. In about 1 billion years, the Earth will become uninhabitable. 1 billion years from now, the sun is only slightly brighter than today. But it is enough to tip the Earth's climate past the point of no return. The extra heat drives more water vapor into the air. Water vapor traps heat, which drives up even more vapor, a runaway spiral. The oceans begin slowly to evaporate into the sky. Temperatures climb past the point where complex life can survive. The seas grow shallow, then they turn to mudflats, then to dry, cracked plains. The water that gave birth to all life, boiling away into space. The green continents fade to desert, the blue planet turns brown, then gray. Long before the sun becomes a giant, the Earth is already a dead world. If humanity still exists, it faces a choice: move or die. Perhaps we will have left for the stars long before this. Perhaps we will shield the Earth or move it further from the sun. Or perhaps by then we will be long gone and no one will watch it happen. Either way, the sun keeps brightening, and the real transformation is still coming. Because in about 5 billion years, the sun finally runs out of core hydrogen. And when a star's core runs dry, everything changes fast. Fusion in the core sputters, gravity gains the upper hand, the core contracts. But the collapse heats the core so fiercely that a new fire ignites. Hydrogen begins to burn in a shell around the dead core, hotter than ever. And that new heat does something spectacular to the outer layers of the sun. It pushes them outward, the sun begins to swell and swell and swell. Our steady yellow star is about to become a monster. A red giant. As it swells, the sun's surface spreads out and cools, glowing deep red. But do not mistake red for gentle. This is the sun at its most destructive. It grows to more than 100 times its current size, then 200. It balloons outward across the inner solar system, swallowing everything close. First, tiny Mercury, the swelling sun simply engulfs it whole. Mercury vanishes into the fire without a trace. Next, Venus, our sister planet, swallowed by the growing giant. 2 worlds gone, and the sun's glowing edge is now reaching toward Earth. This is the moment that decides the fate of our planet. As the sun sheds mass, its gravity weakens and the planets drift outward. So the Earth may escape being swallowed, it may be pushed just out of reach. But escaping the fire is not the same as surviving it. From the scorched Earth, the red giant sun would fill much of the sky. Hundreds of times wider than the sun you see today. Its heat would melt the Earth's surface into a glowing ocean of lava. Any mountain, any ocean bed, any last ruin of civilization turned to liquid rock. The Earth becomes a cinder orbiting a monster in a solar system transformed. Whether it is swallowed or merely scorched, the outcome is the same. The world we live on, the only home our species has ever had, will end. But strangely, as the inner solar system burns, the outer reaches come alive. Because the sun's warmth now reaches far further than it ever did. The frozen moons of the giant planets begin, for the first time, to thaw. Worlds that were locked in ice for billions of years feel warmth at last. Their hidden oceans could surface, their frozen air could melt. For a brief cosmic moment, the outer solar system might become habitable. A strange, final spring far from the dying sun, but it cannot last. The red giant is not the end, it is the beginning of the end. Deep inside, the sun starts fusing helium, the ash of its old fire. For a while, this steadies the star, but helium burns fast and runs out faster. Now the sun has an inner core of carbon and oxygen it cannot burn. It is too small a star to squeeze that core hot enough to fuse it further. So there will be no supernova, the sun is not massive enough to explode. Instead, it does something gentler, and in its own way more beautiful. The sun becomes unstable, pulsing, and begins to shrug off its outer layers. Not in a violent blast, but in a slow, graceful exhale into space. Shell after shell of glowing gas drifts outward, lit from within. They form one of the most gorgeous objects in the cosmos, a planetary nebula. Delicate glowing rings and clouds of red, blue, and green, light years across. A cosmic flower blooming from the corpse of a star. It is the same kind of object we admire today through our telescopes. Every beautiful planetary nebula out there is a sun that has already died. One day some distant astronomer might admire ours and never know we were here. The glowing gas will drift outward for tens of thousands of years, then fade, scattering the atoms of the old sun and the old Earth back into the galaxy. The very atoms that once made oceans and forests set loose among the stars. And at the center of that fading flower, one thing remains. The naked, exposed core of the sun, what is left when everything else is gone. A white dwarf, the size of the Earth but holding half the mass of the sun. So dense that a single spoonful of it would weigh several tons. It no longer burns any fuel, it simply glows white-hot from leftover heat. The last ember of a fire that once gave life to an entire world. And from here, the sun's story becomes the slowest one imaginable. The white dwarf has no fuel left, all it can do now is cool. Slowly, unimaginably slowly, over billions upon billions of years. It fades from white to yellow to a dull sullen red. The scorched cinder of the Earth, if it survives, circles it in the dark. A dead planet orbiting a dead star in a cold and silent solar system. Eventually, after trillions of years, the ember goes out completely. It becomes a black dwarf, a cold, dark, dead sphere drifting in the black. So dark and so far in the future that the universe is not old enough to hold one yet. Not a single black dwarf exists anywhere in the cosmos today. There has not been time. The sun's final form is a state the universe has never even reached. That is how far ahead we are looking, past the age of the universe itself. And yet physics tells us it will come, as surely as tomorrow's sunrise. The warm yellow star in your sky is a fire that is slowly, quietly burning down. Every day is one day closer, not soon but certain. There is something humbling in that, and something strangely freeing. The sun will die, the earth will end, and that makes today matter more, not less. Because for now, right now, the fire still burns and the world is still blue. And that, against the whole cold future of the cosmos, is a kind of miracle. The death of the sun is not just our story, it is the story of almost every star. Most stars in the universe end exactly this way: a giant, a nebula, an ember. The atoms scattered by dying suns become the stuff of new stars and worlds. Our own sun was built from the ashes of stars that died before it. And when it dies, it will pass its atoms on to suns not yet born. You are a brief, warm moment between one star's death and the next. Made of stardust, warmed by a star, watching the sky for just a little while. The sun gave us everything. One day it will take it all back. But not today. Today it is still ours. So step outside and feel it. That warmth is the middle of a story billions of years long. If that shifted how you see the sky, then you belong here. This channel is a map of the strangest real places and futures in the cosmos. Subscribe, and every week we travel somewhere no human will ever stand. Tell me in the comments, if you could see the sun's final nebula, would you want to? There is so much more out there, and so much more to find. Thanks for watching To the Moon and Back. Keep looking up.